Do 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 do. Oh man, y'all missing me sing along with the fucking soundtrack. Hmm. Hey, welcome in. Thank you for the lurk. Always appreciate a good lurk. Or even a bad lurk. I mean, you need to tap out? You need to tap out. I do that all the time, too. Right, where's that last thing? Legends. Where is... There it is. We're just gonna leave that right there. All right. All right. Let's go to chatting. Let's turn on our fake camera background. This one? Or... Ooh, that's old. That is old, Rusty. Current Rusty and old Rusty. I'm even looking over at the shelf, and the shelf is slightly rearranged. Yeah. Oh, am I losing tracking? I'm losing tracking. There we go. Need to make it a little bit brighter for the iPhone. All right. Do we have audio? Audio. Bum ba bum ba ba. Ooh. That little chirp probably from Twitch mobile dashboard. Reminds me, it is from the mobile dashboard. Reminds me, hey, you should post your going live stuff. Come on. There we go. Let's see. First, we are going to do a little housekeeping. Doing a little housekeeping. Let's see if Discord will acknowledge my going live. Self-promo. I think it's funny when you self-promo on basically your own server. It did it! It did it this time. I do not know why. That is a mystery. That is definitely a mystery. Alright. Let's see. Bump there to there. Probably mute Twitch. Let's see. What other kind of bookkeeping here? What other kind of bookkeeping are we doing? We need to grab said, yes, we need to grab that Twitch link. Oh man, there's a good number of people online tonight. That's exciting. Monday. Usually Monday is at least for the folks that I follow, it seems to be a slower night on the Twitch. Let's see. Drop one of these over here and over here. And let's see what else we got. And now I have to grab the invite link because our Discord, we rotate out the invite link, or it rotates itself out. I think it's kind of like a spam prevention. Follow bot prevention or something like that, I'm sure. Okay, we will set that to manually unpin. And let's grab a YouTube link while we're at it. Right. Or neglected YouTube. And now we grab our headphone. Oh, that is loud. We grab our headphones so we can actually hear some music. Get some tunes. All right. And that should be good. No, that does not look good on this fake background. That was old Rusty. Oh. And it looks like I dimmed the backfill light. So this is when we were starting. Same sweatshirt, mind you. Oh man, that's loud. Every Windows update, it updates my audio for some reason. And if that's one of the things that rarely needs to be updated, I would say it'd be audio. Okay, oops, we don't need that one. We need this one. There we go. Welcome in, everybody. We have a stock footage here of old Rusty. Old faceplate, and also, in regards to tonight, old neck. Okay, old neck. Welcome in, Vic. We have stock footage here of old Rusty. Just getting a couple things reset up. We're going to be using Fusion tonight. Apparently, they no longer call it Fusion 360. Full of vigor, so full of hope. So full of hope he was. In comparison to... not that one. Not that one. This one. Newer Rusty. He's got a new faceplate right there. Got a new faceplate. A little weathering on it. What else is different? Some duct tape on the headphone. That was important. That was also important because the kind of turquoise teal color of the headphone interfered with green screen. So that's why we added some duct tape to it. And importantly for tonight, will night tracking reach? It just reaches. This is the old neck. Like old neck. There are 2 small gears and connected to the large gear. Did that help with the traction or the gear ratio? No. But did it look cool? Yes. Did it squeal like a banshee when it got misaligned? Also yes. Okay, I'm going to load in some stuff in Fusion off camera. Because, oh wait, wait, oh, they updated it. Okay. They're changing how Fusion works. So I wanted to get at least one Fusion stream in before it possibly disappeared forever. Oh no, it does still want to dox me in the corner there. Okay, we will be doing application capture for Fusion. Why do they gotta show off your real name for everything? Adobe's even worse. Adobe, you go to the help menu, it's like, oh hey, real name, would you like help? I'm like, no, real name does not need help. Real name wants to see what version he's on. Let's see. Studio mode. Dev screen. And then instead of that one, we go to this one. There we go. Ta-da! And that looks about right. Maybe not quite right. Let's fix this way. It's funny because application capture does a funny thing where it resizes the window by the dimensions to fill the screen when you have it fit to screen. So as you move it around, it wobbles. It wobbles the screen around a bit. All right, then we can close that, I believe. And you know what? We'll open up. Where's the other one? Where is the other one? No, 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 no. There it is. It is not organized in a way I would love to organize it. There we go. 17 herringbone gear. B5. Yes, I believe this is the correct version here. Oh, dang. Kids are playing Godzilla upstairs, apparently. Okay. And a couple little adjustments. There. Was it here? Ah, it was here. And there we go. Switch. Get out of studio mode. Everyone, the program formerly known as Fusion 360. Now, Fusion. And I don't feel bad streaming this because this is the full version, the full commercial version. My trial ends in 2 days. I do like to be a little bit of a stickler for the rules. You know, when I run the personal version, I shouldn't be making money with it, as in streaming, you know, with my whole $1.50 ad revenue or whatever Twitch gives me a month. But this is the full version, so it's the full commercial version. Does it mean I can do anything more than I could before? Not for my purposes as much. Not for my purposes as much. If I was doing more cam, so if I was using my CNC machine, I have a little hobby CNC machine, pretty beefy, you know, for little having a CNC machine. CNC machine. Basically, it's a beefy 3D printer. Think of it that way. Except it, instead of moving around this little plastic dispenser, this little plastic glue gun, which a 3D printer is, it holds a router, a woodworking router, and moves that around based on the commands, the same commands that like your 3D printer works, which Fusion here can output, well, at least for the CNC router part of it. 3D printing, I don't think they have a slicer built into this, but what you can do is you can export as an STL, so you can send it right to your slicer. And Winamp is still too loud for me. There. How's it for you guys? It is difficult to tell due to like audio balancing and ambient adjustments and all that kind of fun stuff. So I do a little test recording before I start, and I still need to put them all. I saved them for the first year. I saved all the test recordings. You know, all like 1 minute of me warming up my voice and such. Just because I thought it would be fun to have that as a thing. There we go. I thought that'd be fun to have as a little compilation blooper. There we go. Outtakes. So, but what you can do, if you are not going to be machining things, like I could make these out of metal. I I can't on my machine because I do not have, I only have 3 axes. 3. There you go. 1, 2, 3. Just like I have 3 fingers on each hand. To make a gear like this, you would need 4 axes to spin it and go back and forth. So like, you could do something like this, more or less, for this type of gear. I could make a regular gear, which does not have the slants to it. See how the teeth go on a slant? Do like a traditional sprocket like you would find on your on a bicycle. Like on a bicycle. But that's not what we're doing here. We are using a herringbone gear because let's see if we can get a good, well, you can kind of see it's this V shape. So with the V shape, really good for 3D printing. Really good for 3D printing because they stay centered, they stay aligned. So these two, well, once this is flipped and realigned, they will stay basically centered because there's 2 little V's pushing against each other as they turn around. So if we go back to the chatting stream, if you look right in the middle of Rusty's neck, you see these light gray, same color I used for the rest of the robot, pretty much the rest of the robot. You see these 2 light gray gears right there. They're making little V's. The teeth are making little V's, and they're opposite of each other because they have to be. Because that's how that works. There we go. Hydrating. Okay. So what we're doing tonight is we are making a different version of those, essentially, which are closer to the more modern Rusty. Unfortunately, the stock footage here, also stock footage, does not show the gears. For one thing, the neck is shorter, and I have, let's see how far my camera can reach here. And let's see if my leap motion interferes with said camera. Do. Bam. You gonna work nicely? Okay, you are looking at my monitor. Okay. Finger jump scare. Giant finger jump scare. Okay. You can tell I really tested this out beforehand. Oh, there's my leap. Say hello, leap. And it's currently blocking part of my screen because that's just how that works, apparently. I wanted to put it up higher. Oh, up this way. But I would have to attach it to my mic arm right now. I don't have anything else I can attach it to. Unless you want a really far away view if I attach it to my main monitor. So that the original neck, the wooden neck, not mech necessarily. Ta-da! It looks, oh, those are some yellowish looking colors. Ta-da! It was carved out of wood. And the little servo, here's a poor example. This is a smaller servo. And right in there. You know, it's the same size. It's pretty much, there we go. It's pretty much the same size as the servos I was using. Or am using. I'm currently using. It's a big brother to this one. A lot more torque. Well, 3 times as much, I think. 2 or 3 times as much torque. So this was the original neck. You had the 2 small gears here. Let's see. I brought some goodies. Is this like is this gonna be my jingling the keys? Jingling the keys for chat. Here's one of the gears right here. See? And here'd be a spare, it looks like. Ta-da! So they would have been roughly right there. It is weird seeing it reversed. Might have to flip the camera next time I think about it. Yep, so these two are here, and then the big gear, which I do not have. I do not have an example of it for some reason. I have a couple of them sitting in my workshop, the spare parts. Yeah, so these lock together and they turn really nicely. See? But we needed to change things. This configuration, unfortunately, because it's made in wood and not all in one piece, it's still cut on. This is actually cut on my CNC. So these are precision hole placement, and this whole shape, well, the top part of this shape, was cut out on a computer-controlled machine, little router. So this way it would match. Oops. So that everything would match up. Focus. Focus. Get my dried out winter hands. You're not going to focus, are you? Well, anyways, these holes precisely match up, but due to the nature of assembling things, come on. Oh, wow, that color correction is way off. Or I need some vitamins. There we go. So these holes, just stick a bolt in there. Stick a bolt in there, and right there. And that would hold the gear. So that's what the gears pivot on. And it's okay that they're on a bolt like this, at least for this one, for the main top of the neck. It's on a bolt because the actual gear, which I will have to remember. I'll have to remember to measure that. The actual gear has a bushing on it. So it's not riding right on 3D printed plastic. It's riding on a nice wear resistant plastic that I'm machined a little bushings for on my metalworking lathe. Precision. Precision helps it not wobble around. And then for this, the middle one, that was sitting on a brass rod and not a bolt. So in theory, it should have spun real nice. But it was just slightly misaligned. So every now and then you get a screech. And the dark spots here, I believe that's super glue. It strengthens the bond of the plywood so that it wouldn't wear down as quickly. So it made it more like, almost like a resin, almost. So we went from that to the first version of what Rusty is currently using, which is this. So this became this. And again, it looks so weird reversed. Is that right? Yes. So significantly shorter, which helped with the head wobble. It shrunk his neck down because all that weight was sitting on this one little spot right here. So this helped with the head wobble, and it strengthened things up quite a bit. So this is 3D printed, and it's same lovely gray plastic. No more wood, at least for this part. So the servo moved from here in the front to the back side. And snapped in real nice. I don't know if this one will. Oops. I don't know if this one will snap. Should we get some possible ASMR? Oh, no. Oh, no, this one won't, because this one was modified. I trimmed away some of the plastic here. But the real one gives a good satisfying snap when you put it into place, attach a couple screws to really hold it there. It was very sturdy for what it was. Unfortunately, this design, I got to get better at ham cam stuff, huh? This design, unfortunately, the gear that's at here had pressure on it, pushing it away, pushing it out the back, which I fixed in the current design. So we're on revision 3, going on to revision 4 of the neck. Here's the old wooden one for nostalgia's sake. Actually, I thought I disassembled it and was using it for measuring. So tonight's gears. What you see, what you would see if I wasn't blocking everything. Those are these. There we go. Let's use that as a base. Ta-da! So there. It's backwards again. Hold on, I gotta flip that camera. That's ridiculous. Oh jeez. Oh. Did I just... That was odd. Okay. We are going to flip. Properties. This hand? This way? Nope, still wrong. Because I don't want to look at my face being mirrored. I want to see exactly what the camera sees. So for now, we will just go into transform and flip horizontal. So now it's roughly what I am saying. So this is this, and this is this. Okay, good. So what we see here is I'm using the wood as a stand-in, or as a shelf. Ta-da! These are the test prints of what you see above the avatar's head. It's a test print. You see it is hollow because I didn't need to waste all that printer ink, the plastic filament, to fill in the top of either of them, to fill in the tops, because it uses probably 2 or 3 times as much. Oh, and I've got an ad break. Sorry about the ads. Because I just needed to see if they would mesh. And by mesh, that means when the gear teeth line up real nice. And they do. They're almost a little far away. We've got a little wiggle room. This is set up for a 79 to 16, so a 5 to 1, roughly a 5 to 1 ratio. Why 79 is a weird number? Because 80 teeth was just a smidge too big. It was a little too tight. So we can test that out. We can show you. Maybe we can show you. There we go. Duh. Now maybe this would wear down enough, but it turns so much more difficult. Yeah, no, this wouldn't wear down enough. So I made it 79 teeth using the gear generator on the left side of the screen. It works in the middle here because this is flexing. See that the way that the waffles are printed? This moves just enough. The plastic is just flexible enough that it doesn't seem as bad as it is. Okay. There we go. Now I got the idea to use this size of tooth, this size of gear, from a 3D printable, and the design of how it attaches to the stepper motor. I got the idea from a 3D printed camera pan tilt slider. There we go. So take your actual camera, your DSLR, webcam, phone, whatever, and hook it up to an Arduino, and it would zoom back and forth and tilt forward, backwards, and rotate left to right. And one of the gear sets was this one. See, I'd say it meshes together nice, but unfortunately my 3D printer has a little bit of what's called elephant foot. And I don't think you'd be able to see it here. But basically it squashes the first couple layers down a little bit. So it's not quite lined up. I accounted for that on the test prints though. So we'll be able to print our own gears successfully. So if you look, there's a slight difference in the size of the teeth. So it'll give us a little bit better traction and also a lot more teeth. And a lot more teeth means we can go to a much smaller gear ratio. There. See how much smaller this is? So we'll get a lot more torque, more power, more bang for your buck at the expense of the motor having to turn more. So when I'm using a servo motor like I currently use on Rusty's neck, not this one because this one's bad. See, it says so. Maybe. So this one's bad, but these servos I have, they only turn 180 degrees because all these gears like this are on the inside. They're all pretty much right in this part of the box. And so all those little gears there. So the output, this part, only turns 180 degrees. So this way to that way. So the current Rusty's neck is a 2-to-1 ratio. So this little gear, basically right there, will spin twice around to move this gear once, the much larger gear, which is over on his neck. Way over there. See, there he is. There's Rusty. Okay. Move that over this way just a little bit. There we go. Which one is this? See, past me was thinking of future me. This is 80T, so 80 teeth. And this isn't the full gear. I can bring that up on Fusion and ditch the ham cam for now, because now we know what's up. Might pop it up again. There we go. Ta-da! Here's the 79 tooth back in action. So I could pop that in right here because this is the same distance as this little T piece. T. I don't know why it says I. I'm not entirely sure about that. This piece controls the side to, or holds the side to side gear, which on the screen is right here. There. This must have also been a test piece, so I don't think it has the It looks like it doesn't have the hex, the indent for the bolt right here. Yeah. But it's the same distance because I wanted to keep things similar, which we're getting away from now, unfortunately. So now the two gear sets will be different instead of matched. But the side to side is also a 2-to-1 ratio. It gives it strength, and his head doesn't need to go 180 degrees. The original idea, though, one of the original designs, is that Rusty's head could be horizontal or vertical. So that was one of the original designs, which I abandoned for simplicity's sake. So yes, his head could originally completely flop side to side. So the side to side wasn't going to be geared at all. It was going to be right on the servo. Yeah, that's that part. Okay, so what else I got in my goodie bag? Well, we had a failed gear with larger teeth, or what's called a different module. You can't tell super good from this one, but these are different types of gears. And how you generate the gear is important, especially in CAD software. There, I think that's all for my goodie bag. My goodie bin that I'll keep around to jingle my keys. I do keep most of my 3D printed parts, even the failures. Because for one thing, it's plastic. You can maybe use it for something, you know. Maybe I can scavenge something from this down the road. You know, chop off this part and boom, I still have a servo mount. I can just bolt this down to something else, maybe. This, well, I didn't want to burn this. It's his original neck. I'm not going to reuse it. I'm not going back to this style. For one thing, the servo, where it was mounted, rocked back and forth a bit. But it was his first neck. What did they used to do back in the day? They used to like bronze baby shoes. Oh, here's the good. There we go. Here we go. This was laying down by my feet. Ta-da! There we go. We're going from this to essentially this. Yeah, that way, no. There, this. It really doesn't like to stay. There we go. There. So this plastic, this gray part, is the same size as what he's currently using. It's just that it's completely redesigned, so it would take the stepper motor, again, like on a 3D printer, or a small hobby CNC machine. And yeah, that's the size difference. So let's get gearing. Let's get gearing. But the thing we are going to do is we're going to put a smaller, much smaller gear on here. We're saving the rest of this. We're not changing any of this. But tonight we're finishing up this gear. Then we're also going to make the gear it connects to, meshes with. When two gears are working properly, they are meshed. Okay, so I'm going to turn off the camera for now and get it out of my face. Well, not my face. My hand's face. Oh, sure, the hand tracking goes way over there. I need to move my leap around more, I think. Okay. Just for fun while we're in here. Oh, yeah, see, here's... I don't properly split my files apart. So here is the piece with the stepper motor. There it is, mixed in with everything else. And I have a whole bunch of stuff hidden in the assembly right now. Let's see, neck joint. Get back over here. Ta-da! Yeah, it is not properly spaced, but it works just fine. Mostly I wanted this piece in the middle. So here you can see that they are identical halves at 90 degrees to each other. So you can get the nod and the side to side. And then these two smaller gears, which are 16 tooth. 16 big teeth. Those were the original wooden neck. Currently, we're only using one of these and still the same original neck assembly. Original neck assembly. Oh, look at that. Fusion saves the background color per file. Well, that's interesting. Okay. So everybody. I was working on this the other day, getting it all situated. I was like, okay, let's get this 3D printed so we'll have it ready for stream. And I paused and I was like, why don't we work on it on stream? You know, some more robot behind the scenes. So we're not just, playing video games with the robot. We are we're working on the robot. Because I probably won't be doing a whole lot of coding of the robot on stream. Because by this time at night, my brain is relatively fried due to, doing coding all day. But then also, I have a toddler that likes to wake up at 4 in the morning. So by 9 or 10 p.m., it's a wee bit late. All right. Oh, and we're hiding in the art category tonight instead of the makers. Yeah, we're not hiding in makers. Or no, not makers. This could go in makers and crafting. That might be a better fit, honestly. We're gonna go run over to makers and crafting. I'm gonna change the thing. I was thinking usually we hide in software. Makers and crafting would probably be a much better fit, honestly. There we go. Because we're doing CAD stuff. Okay. So, but yes, I thought, why don't we just do this on stream? I already have it sketched out. So in Fusion, one of the ways to generate shapes is to sketch it. Let's pick a perspective, non-perspective. Okay, so basically I'm using a gear generator because I'm not drawing this. Theoretically, you could do it. I could do it in like Illustrator, probably. Map out the shape of the tooth and then rotate it by a correct number of degrees. And then take that line art, bring it into Fusion, and extrude it. Got the extrude tool up here. Yeah. Ooh. Oh, you don't get the nice pop-ups because, yeah, I'm doing application capture instead of monitor display capture. Display capture. Window capture. There we go. I think I'm doing window capture, so you don't get the nice pop-ups, but we'll just have to deal with that for tonight. So what we have here, get a little more centered. We have the gear. It's already herringbone, which means it's a helical gear. It means it's the teeth are at a slant. But then I copy it, mirror it across an axis so it looks like a V instead of just a slant. What I mean with that, let's go perspective again. Perspective. So this is the helical gear that it generates. Yes, but then to make it a herringbone is basically just 2 helical gears pasted together, as far as CAD is concerned. Yes, so this one's already set up, much like the bigger gears that Rusty is already using. These guys, see? We're just making them with more teeth, smaller teeth, and a different ratio, different power ratio. So I already have it drawn out on how I want to, there we go, on how I want to extrude this. So what we have right now is we have it set up for a stepper motor shaft. I did the measurements. So with the stepper motor shaft, there's a little flat piece. So it's round. And then there's a little flat, which you can then attach pulleys and whatnot to this flat. So that hole's already done. I've tried it and the printer does a good enough job. My 3D printer does a good enough job. I can slide the gear on there and it stays put. But I want that little extra bit of insurance so the plastic might not just rip out. So we're going to also add a, zoom in, there we go. We're also going to add in a spot for a little nut and bolt to press against the shaft like a real pulley would have. It's called like a set screw or grub screw. I do get those confused, even though I've worked with them for decades. Not often enough, obviously. But it is a way to secure it. It also keep it from wobbling back and forth. So, how far do we need to go? Get my trusty calipers here. And I'm taking dimensions off of that camera slider with a different size gear. Sadly, I couldn't just use those gears right off of the rack. Okay, we're going with 8. We're going with 8, and we're doing a little bit different shape. So this is a sketch that I've drawn. Let's go. We'll be using a sketch again soon enough. I'll show you then. But basically, I've drawn out these shapes. Now, okay, fine. Twisted my arm. Twisted my own arm. Edit sketch. So instead of doing everything one operation at a time, you can lay everything out first before you do it and use that as reference point, or, and what I like to do is setups for extrusions. What we're going to do here is, yes. So I left a flat spot on top for the bolt, and this is where the hex nut. So it's a hex bolt and hex nut. This is where the hex nut's going to be. So that the bolt stays put and it can press against the motor, hold it in place. A lot of talking for a simple thing, fairly simple thing. Okay, we want this, and for now, this. Oops, I'm gonna finish the sketch. Extrude 8. So that's 8 millimeters. Doesn't seem like much, but this is tiny. This is pretty tiny. Okay, and we're joining. So we're yes. Oh, you're not getting any of this. Oh. I will have it set up differently the next time I do a CAD stream here. Does it get doxy? I mean, I did change my team hub to Rusty Industries, so I think we're good. I will, if anybody has any questions, I will step you through it. Okay. So we made the hub. And now we need to cut a slot into the hub. Where am I? Where are you? There we go. Okay. Make you invisible for now so we can select the stuff. Take this, and I believe... Yep, we're just cutting this... Oh, we're cutting this rectangle back into it. So now I want to see this again. This time we're using slightly different settings. We're going to extrude. We'll make that 8. But we are changing how it extrudes. We're going to change it so the bottom, so that it extrudes from this plane, the top of the gear, but with a offset. Let's find out what that offset is. Now, I should really take it off of the gear I'm currently using. Hold on. There we go. Much better. $2 millimeters. 2 millimeters. So -2. And this operation is going to cut. Bam. Super simple. So now we have a little spot right here for, we can hide our sketch. We have a little spot right here for a nut. A metal piece to help strengthen the plastic pieces. But we're not quite done because we need a hole for the, we need a hole for it. What size do we have? 3. 3. And we are not far from the edge. 3.5. I'm going to narrate a little bit. That's the hole tool. Narrate a little bit because unfortunately window capture not do its job. Let's see. Window capture doesn't show the windows. Doesn't show any little pop-ups. And this problem with Maya too. And I imagine any app that does such. 3.5. Make sure it's deep enough. I do love how it gives you a little preview. Yes, so this will cut plenty deep. There. And now we have a hole. Simple as that. We don't have to worry about polygons or anything because this is solid modeling. It is what you see. What you see is what you get. It is solid. If you want it to be hollow, you can worry about that in whatever you're using to machine or create the physical piece. In my case, it'd be a 3D printer slicer software. Or you can use some of these fancy tools, which you won't be able to see because they're in the menus, to effectively hollow out. So you can control in the CAD software how you want to hollow out the piece. If you want to have thin, if you want it to have 3 millimeter thick walls, 3 millimeter thick shell, basically, you can do that. That is a thing you can easily do. And a cool thing about this, and I'm sure probably other CAD software, if you see this timeline, if you see down here, all these little icons, these are all operations. This is effectively, I could Control Z through them. These are all the steps that were created to make what you see. Everything you see. So even if I'm selecting different pieces, it's all on one history timeline here. Cool thing is, well, we're not far enough. I got Winamp blocking everybody. But so I have this piece highlighted. Oh, let's do this hole over here. We have this hole I punched in here so I would know the distance. That hole is, again, blocked by blocked by Winamp. Here we go. How's this one? This was part of the gear generation right here, where it made this top surface. I made a few trial pieces, so there are lots of gear generations in here. But yeah, this piece is done. We can now send this to the 3D printer. Almost done. Almost done. I do have to do one little thing. Let's see. We are going to... Will it let me chamfer? 1. No, it will not let me do 1. Will let me do 0.5. Yes. Okay. So earlier I said that my 3D printer has a problem with something called elephant's foot, where kind of squishes the bottom layers of it. It's very annoying. A way around that is to add this little chamfer. You might call a bevel, but it's a chamfer. Essentially thinning out the bottom of the piece, in this case, to counteract the elephant's foot. I think 0.5 is enough. There, and that should be good. It's especially, most pieces it doesn't bother me. Like structural pieces, it doesn't really bother me having that. I can usually sand or slice off a little bit. These are teeth. There are 16 of them here, and there's going to be about 40 of them on the big gear. I don't want to sit there with a tiny file, which I do have, over on my workbench. It's a tiny file. Zip each and every space in between the teeth. No, thank you. So we do this the right way in the first place. Or the easy way, at least. The easy way in the first place. Okay, so that gear is done. We're gonna do the same thing to this one. However, I'm wondering if we want to redesign it a little bit. So here's his current neck. So here's his current neck, and it is a little more than 180 degrees of the gear, because this hole is the pivot. This is the center of the gear. It goes a little bit past that, just to make it easier to mount everything solid. Technically, I could have chopped off some of these edges, and it'd be just fine. He doesn't tilt forward or backwards 180 degrees. And I really don't want him to. So I think for now I'm going to duplicate this. Let's see how wide. See how wide these pieces are. Does it say? It does say. There you go. Some of the things pop up. 20 millimeters. We are currently working with 8 millimeters. And these are glued together also. So these are the exact same gear, same orientation and everything. The exact same gear. And then there's one is rotated and they're glued together with super glue. And they do not come apart. I left little tabs here to kind of guide them and lock them in place, but also if I needed to put screws in, no. Super glue. So it's a 20 millimeter by 20 millimeter connection. And it is held for over a year now. So we'll need to make a 20 millimeter spacer to connect to all this. I'm going to have to pry them apart. Not looking forward to that. I am not looking forward to that. I might have to reprint this gear, the top gear, instead of detaching it from the bottom one, which isn't the worst, but still, wasted ink, waste my 3D ink. Okay, but we need way more than this this little pie slice right here. We don't need to regenerate. I was thinking we might need to regenerate this gear here, but haha, we have the whole gear. This one. So I just need to find where we sliced it. Is it this operation? That's a combine. Extrude. Mirrored. Pardon me, I'm talking to myself here. So that's the hole. Here we go, sketch 7. What steps use sketch 7? Right here. Okay, so I extruded a shape that cut away. So See, normally when you think extrude, you think you're making things thicker. You know, you're taking a shape and you're pulling more out of it. Well, in this case, you can also pull something up but cut away. So what we're going to do is we're going to edit this sketch. We're going to go back in time. We're going to change this. We have this Pac-Man. We're going to take Pac-Man and make him less Pac-Man. Okay, the pivot is, the circle is right here. Let's do a little more measuring. Which honestly, I could measure right in the 7.5. 6.7 is that? That doesn't work. I'm going to measure actual Rusty. BRB. Roughly 10. Roughly 10. I suppose I could be more precise. I could be a little bit more precise. In a sneaky way. There. I would say almost 10. I don't know. Nope, you can't see the little... I will figure out a better way for this next time, if there's another next time. It is 10. 9.94 according to this. So we're going to do the same. We're going to do the same right here. So we get as much space as we need to. One of the wonderful things about CAD is you can kind of do what you want. So that line, yeah, basically we want to cut this whole thing down. Right to there. It was that easy. That is as easy it is. Like I said, we are going to need to make spacers to hold the wider gear to the thinner gear. But I'm not certain if I want it like offset now. Because we have a lot of space right now in his current neck. And that space doesn't need to be there anymore because the gear is going to be so much narrower. So I'll be making a little adapter piece later. Because I'm gonna have to reprint the side to side gear. Let's see. I'm gonna have to reprint this top gear anyways. Because it is glued very, very well to this piece, to this gear. So when I reprint it, I will move these little tabs, these little ears, gussets. Well, these might technically be gussets. We're gonna move those in just a little bit. We'll figure that out later though. That'll be a problem for later Rusty. Current Rusty. Current Rusty is good to go. All right. So we have the hole here. And we have all of this here. So we finished this. We edited the sketch, and now that will update. That will update the shapes that are already out there. Completing extrude. It had to think about all that fancy gear stuff. And now we go to the extrude. Is that this one? This one. Where we cut away. Oh, topsy-turvy view. Come on. There we go. So not that one. Not that one. This one. There we go. So we're going to go back in the past again and edit things. There we go. Ta-da! You can see here's where I extruded the Pac-Man shape. Now, a fun thing we can do is just that. We're done. Well, we're almost done. Too little hanging on pieces. But there. It has to think a little bit. Normally it doesn't take this long to think, but also normally there's not a whole bunch of these complicated looking angles all over the place. So there, now we have the right shape. It already has the same hole in it, the correct hole. So it looks... Oh, that hole was dependent on where the cutoff line used to be. See, I figured there'd be a problem for current Rusty. Still though, I absolutely love that you can just go back in and edit features. I'm just gonna plot that right there. 6.41 millimeters. Is that about the right size? That is not the right size. Uh-oh, uh-oh, uh-oh. For a second there, I thought we crashed. So this hole is significantly larger because it has a bushing, little machined plastic piece. Little machined plastic piece. Let's find out how big that is. Okay, diameter is 9. You can't see, but there's a nice little tool window, a little info window over here that tells me what I clicked on using the measuring tool up here, the inspect tool. It gives me the radius, the diameter, the area, and the loop length, which I assume is the circumference. Okay, so 9. That makes sense now. So where were we? Yes. Editing features, because why do it twice? Why not just go back and redo it once? That's exactly 9? Okay. There we go. Fixed. And it's directly on the origin point, so that's how I know it's where it's supposed to be. Now we do the easy part. We take this, we save. We're going to save. And I'm pretty sure these are oriented the right way. I might have to think about that one. And then we just mirror it. We're going to move object body. Or do we mirror it? Do we mirror it? Oh, we mirror it. Sorry. My mistake. My mistake. You would think I was just in here the other day. Mirror, there it is. For some reason, mirror is under create instead of modify. Mirror plane, join. And now we have a helical gear. Ta-da! And it looks like they're pointing opposite of each other. So big success, big success. Yeah. Now we can print it. This one does not need the little hub. It does not need this part on it. Because again, this piece gets a little bushings put in it. Which I could just bring Rusty's head over here. I could bring Rusty's head over here. Yeah, there we go. Gears. We've got gears, folks. Gears of Robot. Beautiful, beautiful. Let's turn off our sketch. Make a screenshot. Boom. Okay. And then to send this to the printer, yeah, we could do that. We could do that. Let's see, the little gear shouldn't take too long. I mean, we're not going to do it tonight. I thought about it. We're not going to do it tonight, but I thought about it. I'm going to save. Here's herringbone. Okay, so we select our piece, our body. Go to manage. Nope, we don't go to manage. We go to utilities. And this is available in the personal version too. Over here. Again, you're not seeing my darn windows. There's a little export. And I think I just left on the default settings. It says output selected object, which is the blue because it's selected. I'm outputting it to an STL, which is a, what does it stand for? Standard something lithography? It's for 3D printing. And we hit OK. And I'm saving everything on my desktop because that's where it goes. Oh, you're not getting this window either. 16L gear. Save to... Ew, not whatever. No, not that folder. No, I don't want it in that complicated folder. I want it right on the desktop where it can annoy me until I move it. Okay. Now you get the void. You get the void until we do this. Hello. Okay, and then 16lgear.stl. Oh, standard tessellation language. Oh, lithography, something different. Standard tessellation language. Huh. Oh, I could have swore I had this in gray. Yeah, I'll get flashbanged. Okay. So I use Cura. It's nice and easy. But here, look it. Here's our little gear. And this is set up for my, I have an Ender 3 V2. There we go. And settings that I found have worked out great for gears, specifically these gears. So if you look at the bottom, see this teal, this lovely, hey, it matches my eyes. Look at that. So this lovely teal. If you look on here, this is what will be touching the printer bed. So this will be the first layer that's printed once I slice it. So you can see it's a little bit smaller. Hopefully this counteracts my, it did at least in the test print I've done of a very similar gear. It counteracted the printer errors. I just really need to calibrate it and adjust the tension, look up more tutorials. Most time it's not a problem. What could be a problem is this little hole right here. "37 minutes. This will take 37 minutes and use 2 grams of filament. Oh, it'll use more than that. This is again for the test piece, which does not have a top or bottom. Let's change those back. Okay, we're gonna have 3 walls. We're going to have 4 tops, 4 bottoms. Oop, not 44. There we go. There we go. Now it's going to take a couple more minutes, 5 more minutes, and use 3 grams. Not much more. Not much more for this tiny gear. It makes a big difference for the 79 tooth gear. But see, there you go. There's layer 1. And it quickly adds in more layers, or more thickness. Grows up big and strong. Does a little boogie woogie as the teeth change direction. And there we go. And my printer's good enough with the with doing overhangs that I can do circles like this with. It's just slightly oblong, but it does just fine with circles. There. Beautiful, beautiful. And we're just gonna save that. And call it good. Oops. Oh, my windows are janked up. And you know, we can do the same thing with the other one. Fusion. Hey, look, you get actual fusion. Select the big gear. 3D print. Oh, here's the here's what the windows look like. See? So I selected the gear, set it up for export using this lovely make button. I just hit OK. I'm okay with the default settings. We'll call this 79T here. Saving to desktop because I'm a heathen. Let's minimize that. And load it up in Cura. This one is significantly larger. Significantly larger of a gear. Let's see. There we go. I like moving them around every now and then, so I'm not always printing in the center of the printer bed. But yeah, significantly larger. I'm going to leave the exact same settings. We have to go back in and shrink the teeth thing. Yeah, this one's going to use, this one's going to take 2 hours and, there we go, 2 hours and 49 minutes, so almost 3 hours. And it's going to use 5 times the filament. Nope, I need to change more settings. I just thought of this. So it's a good thing I'm doing this, you know. It's a good thing I'm doing this and talking it through. So, if we look, this is using a grid. What do they call this? The grid infill. Yes, grid. What I like to do for gears, especially if they're going to be doing a lot of work, is we go down to gyroid. What is gyroid? Spaghetti. It's funky spaghetti. So what it does is it draws zigzags. And it looks pretty funky. But what it's doing is it's rotating those zigzags. Or not zigzags, because that's a different thing. Those curvy lines, it's rotating them as it goes up layer by layer. And it makes it really, really strong. Like incredibly strong. It doesn't take that much longer either. It takes almost the same amount of time. But it's funny watching it print because it just goes like this, back and forth, back and forth. Both the printer head and the bed. Just wiggle, wiggle, wiggle. Yeah, but this is significantly stronger. I only really use it for gears. Otherwise, I like using cubic. And just for fun. Just for fun. This is cubic. Kind of like triangles that change shape and look kind of trippy. So it's a grid of triangles. And that's what I use for anything that's more structural, because it can take the force from pretty much any direction. So like the support brackets, so the sides of Rusty's neck have the cubic infill. Okay, but this is a moot point for this because we need to put that bevel on the bottom first. Clear build plate. Go back to Fusion, capture. Okay, so one thing about Fusion that I don't really care for is you can't just select you can't just right click. There we go. Like in what we were just doing, you can't right click and swing the view around. You have to click or orbit. You have to click the orbit button on the bottom and do it. Okay. So we're going to take this, go to the body. Put that little chamfer on the bottom. And I'm thinking a 0.5 is enough. It looked like it would be enough. There we go. Little chamfer on the bottom. And just for fun, we're going to put one on top too. I'm waiting for it to calculate. Because this calculation will take longer because it has to make these lovely little chamfers on each tooth. Like, look at that. All these little angles it has to calculate. I'm going to do the same thing to the top. But yes, 0.5 millimeter looked like a good amount. We're doing the top just purely for aesthetics. Sorry, spammer bot. You've been caught. And it looks like SiriBot was the winner of the Catch the Spammer race. Okay. Yes, so now we can select this and bring it into the 3D software. We're going to overwrite 9T gear. Yes. I don't keep anything doxy on my desktop, mostly for streaming purposes, but I don't know. I'll show you some of the pictures in there. It's kind of fun. Okay, but first, I'm gonna switch the infill, the gyroid, and what was the other thing? Top layers. Okay, we got the layers set. We've got the layer height, 0.12, so 0.12. What I remember reading when I first got my 3D printer, reading up on everything, watching videos, is you want to go with the type of printer I have, you want to go at a multiple of 0.04 for your layer heights. So 0.12, 0.16, and 0.2 If you really want to go fast, 0.24, which I haven't used. So this is a good combination of settings for what I'm doing. I don't think I need to go any higher in reinforcement. This isn't a gear that's constantly turning. Then I would do something a little different. If it was constantly under load in a transmission or some kind of gearbox. But that's not what we're doing. That's not what we're doing with this guy. We're making a funny little robot nod his head. Yeah, that should be plenty of reinforcement for what this is. Most of the strength is honestly coming from the 3 walls. So if you look, 1 red, because that's the outside wall, and then 2 greens. I found out that's plenty of reinforcement. We're just going to save that. Oop, get over here. I'm going to save that and call it good. And immediately load up that other one and fix, because otherwise I'm going to print the wrong gear. 16L gear. Let's see, where are we? Move you that way just a little bit. Dun, 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 dun. Gyroid settings, blah, blah, blah. 41 minutes. Okay. Done. So welcome to my gear talk. Welcome to the gear talk. That was about it. Oh, there was going to be more hand cam stuff. So those were the gears. I've been talking a lot about, I'm going to load it up first. There we go. We are going to load up Unity. I want to tell everyone, remind everyone, where these things are. Yes. So while Unity's loading, because that does take a minute now. Let's see if I can get the camera back over here. Big reaches. There we go. Where are you? Oh, it's my monitor. That's my monitor I'm not using at the moment. There we go. And again, my Leap Motion, my keyboard. Probably a face in there somewhere. There we go. So I took the gear off the stepper. So here was my test gear using the original gear sizes, and then changing, the original dimensions, the tooth size, everything, but then adding this little feature. So if you look carefully, this is the little hub. It's called little hub that we made today. It's going to hold little nut and bolt, and that goes on the inside to reinforce it. The bolt is to keep it in spot, keep it in place. This bolt is just a smidge too long. I'll just grind it down. Hello, Nix. Welcome in. Look I have hands. And the auto white balance makes them look very, very yellow and windburned. But we just finished up. We finished up finishing these test pieces. So this was the test piece for Rusty's new gears. I think I posted in the Discord. I might not have. So this is a test piece. It's not a little hollow. Won't hold a whole lot. This is going on the motor. It's a little bit smaller than his current gear. A little bit. We'll get a little bit more power. It's going to look more like this when it's finished. A little bit more like this. And we just finished getting everything off to the 3D printer. Because you missed the exciting CAD. There we go. There we go. Exciting CAD. Ta-da! So if you look, reverse angles are funny. But yes, this is basically this. Except finished on the screen. Yep. So this is going to go on the stepper motor, and this is going to attach to his neck. Except I have to reprint the current gear that's there too. So it'll be a little extra 3D printing. This is the little CNC board. When I say CNC, I mean computer numerical command. So this is what's called a CNC shield. Arduino calls them shields. Pi, the Pi stuff, Raspberry Pi, they call them hats. They sit on top of the main board. There we go. So here's an Uno. This one's a generic off of AliExpress, and so is this, because I didn't want to spend a lot of money on something that might not even work for my purposes. But here we go. I only have one motor that's going to be hooked up to it at the moment. One stepper motor, I should say. The servo motors don't use this. They use something more like this, the slightly bigger version of this that's currently bolted down inside of Rusty's head. That we modeled up last Monday. That's right. That's why I brought up the other screen. So this purple piece right here, it's called a driver board. A stepper driver. So you need this piece, the main control board. This, which is a circuit board with extra pieces. Extra pieces do all these little extra things I'm not going to use. Like limit switches for how far your machine can go back and forth. This is basically the same thing as in a 3D printer too, basically. But I can control one little motor here. I've up to 4. Here's the power. This goes to a 12 volt power supply. Got a nice little power jack on it. And this will plug into Rusty's main board. For now, it's just sitting on here to protect itself, because we're not using it at the moment. Well. Oh, that wasn't much of a snap. Sorry you don't get snap ASMR. There we go. But this is why we're in Makers and Crafting right now. We're hiding out in a different department. Yeah. Oh, it's funny how much larger the motor is than anything else. Because we will be using the stepper motor and putting, well, I'll just use this as a stand-in. Essentially, this will go right onto here. Whoops. Find the flats. There, pretty much like that. See, so that's a little bit smaller than that guy. And this one wobbles. Mine fits, I designed it so it fits just nice and snug on there. So another motor comparison. There. A little bit different sizes. And they do very different things. Okay. So remember that control board? That guy right there? Oh, so for scale, before I start, using Freedom units, this is a quarter by 2 inch bolt. in freedom units. In what is it in non-freedom units? Where's my rulers hiding? It's roughly 50 millimeters long. So that's about how wide this board is. So 5 centimeters, not very large, not very large. We're going from gear of about 36, about 35, 36 millimeters down to one that is significantly smaller. Get in there. About 18 millimeters ish. All these fun measurements. So digital calipers. Won't show up too good because it's an LCD. But basically it measures anything between here. You can even measure, all sorts of different surfaces. You can measure from this flat to here. Really, 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 really handy. It's like 20 bucks on Amazon. Totally worth it. For hobby machining, like I do. One of the other things I do is have some metalworking equipment. I do hope to show on stream again. I'd say go look at the workshop stream, but the workshop stream, the VOD is no longer up. So I need to get that, I need to get working on that. Add more and more videos to the VOD page on YouTube. I think I only have a couple of them on there right now. Oh, but I did find, I have a very old metal lathe. I did find this cool picture. This cool picture of some fine gentlemen in the IBM machining lab using almost the same exact version of the lathe that I have for working metal. So it's a an old precision metalworking lathe. Basically, a lathe makes round things smaller by cutting away metal. Is super simplifying it, but I thought this picture was hilarious. Not hilarious, but very interesting. It's like, wow, IBM was making some kind of electronics parts. They got a bunch of lads here, ooh, and some supervisory types using the same machine I do. Let's see if I can find a picture of mine. Should be fairly easy if my hard drive spins up. Because I will need to make some more parts for the robot. And I was thinking, you know what? Why don't we do that on stream? It's like, what can I do on stream and maybe expand my horizons? I don't know how to. Variety. There we go. Add variety. I know I got a picture of this, the old beauty here somewhere. Really? Well, while I'm staring at this, we might as well load up a little bit over here. Bam. Make sure that's loading in, so we can continue the rest of our work here. See, I thought I had some images of images or video of me making some of the robot parts. I swear I had them on here somewhere. Interesting. I will have to go hunting those down later. Because for one thing, I want to see them. But in the meantime, oh, here we go. We got it right here. So that circuit board, here's its big brother. The actual circuit board in Rusty's head that we modeled up last time, I believe. I think that was last Monday's endeavor. Speaking of schedules, while I've got y'all here, we will not be having a Wednesday stream. Got some stuff going on IRL. Won't be able to have a Wednesday stream this week, but we should be back to our normal schedule next week. The Monday, the Wednesday. I really wanted to take a day off at some point to take a day off, but a lot of that's going towards my kids. Sick time, we had a snow day, we got doctor's appointments, all sorts of fun stuff for my little vampires, my little time and energy vampires. And that's okay. But I do want a day for myself at some point. So we'll have to see about that. We will have to see something about that. No, I'm not seeing any robot pictures. Well. I will have to dig up a robot picture and put it on the Discord. Be machining stuff. Yep. So there. So instead of me staring at it some more and trying to see if I did any of it, I'll just show you all later. Oh geez. Okay, I did find one picture. Save as. Really? There we go. Oh, no, come on. Here's an old picture. I have since changed a lot on here. I've done a number of upgrades to it. So this is an old picture in a different basement. Yes, there's the same lathe that those fine gentlemen were doing in their fancy lab coats and such. It was made in 1940, I want to say 1943 or 6, probably 1946. It is not a World War II vintage. In the US, most of the machinery was put towards the war effort. Machinery was put towards the war effort, so they sprayed different paint jobs on them and such to signify that, whether it was for like Army or Navy use and such. But nope, this one doesn't have that. So I think it's in 1946. A little bit older than Rusty here. Yes, we will have workshop streams again. Soon. But tonight we are going to add more to the Rusty. And we're going to have to update this. I was just thinking about this. We are going to have to update this this layout now. Because down here... Oops. No, come on, get back to that gear. Get back to the gear. This will work. This will be different going forward. These will be different gears. They'll be significantly smaller. And this is just his head, so I don't think I'm going to add in the side brackets for the neck and everything. What I might do is I might have him like laying down on the floor or, being pressed up against the wall or something like that. Yes, we have our war table here. What we're going to do is add a... Probably just for now, I might just add a collider to just that part. Let's do a simple box collider. I believe it takes care of it by itself. It does. Okay. Unity is fairly smart. And it basically made a box around the extents of where it needed to. So that's nice. We've only got a little bit longer, so I don't think I'm going to do any more modeling. Modeling in here, or in Maya. I don't think I'm going to load up Maya to do more. Is what I'm saying. But what we should do, what we should probably do, is add some more junk in. So design-wise for Rusty Land here, I am going to be moving some of these around a little bit, some of these features, because I want there to be a tunnel. So instead of walking out this door here, I want it to be more of a tunnel into this building, because this building is submerged. The lower level is submerged. So I think it'd be more fun if we go down some stairs. If this leads down some stairs, and we separate these two buildings much further apart, so it takes a little time to get there. And maybe if we run into memory issues or such, it'll be loading time. So that corridor would be the loading screen. Yeah, think about this level design stuff, which I haven't thought a whole lot about, to be honest. So I should give it a little bit of thought, because we are still dealing mostly with the what's left of the example, the demonstration level, which does remind me, did I add them yet? I did end up purchasing the construction bundle. Oh, it's not in here. I did end up purchasing the Cinti has a Humble Bundle right now. So if you go to humblebundle.com, I'll find a link for it quick. If you go to Humble Bundle, great place to get stuff. And support charity. You're still supporting the creators a little bit. I mean, they're basically donating it. But then you're also supporting charity, whichever charity that particular bundle of things goes to. There's more. Well, they have a whole bunch of them on here now. They must have just switched it up. There's a 3D printing. Let's see, where are we? Okay, good. Just make sure I don't have anything suspicious on the screen. There we go. Really wants to stick to the edge of the of the screen. Okay, so it looks like currently for their software bundles, they have some Learn 3D game stuff, RPG Maker bundle. That's cool. New game dev environments. That's pretty neat. Or could be. Get that promotion. Get that promotion. Fallout TTRPG. Let's see. Some minis you can print. We're going with this one. They also have games. Oh, they only have one game. Usually they have a lot more. Maybe they don't want to compete with the Steam sales, or the publishers don't want to compete with the Steam sales. You can tell. Can you tell that I've been up since 5 this morning? We're starting to coast to our finish here. Let's see. For books, they have a mix of Pathfinder, some other gaming, learning Python. Ooh, self-reliance and off-the-grid skills. Now, not sponsored. Can't vouch for any of these. Some, they're hit or miss, like anything. Not everything will fit your tastes, which is fine. It doesn't, not everything needs to, right? But I did pick up this one. The Best of Cinti, number 4. I think I was missing one of them. It happened before I discovered that I wanted to do this kind of thing. But yes, so we got some simple interiors, exteriors, which I don't really care for. They're a little too low poly, too simplified. But what we did get is the construction pack. And some cool particle effects and the locomotion. So we'll get better animations. Including something exciting, possibly a better character controller. It might be all set up, so I don't need to manually add in all the animations, the states, the cycles. So we'll see. I have to try this one out yet. Either way, we'll get some, if nothing else, NPCs will have some fun animations. But I did get this. I am excited for this one. Move that over here for a second. I don't remember if I went through this on stream or not. But yeah, stuff, rubble, some construction equipment, some bare buildings, build out kind of stuff. And these are finished renders, they put the time in to make this look good. All you get is the bits and pieces, but still a lot of cool construction equipment and stuff. I've been wanting some of those for other projects. For instance, 3D print them, because you can just 3D print some of these. So that's exciting. I'm not going to load it in right now. I'll do that off stream. Load it into my asset project that we've been working on for a little bit now. What was this, like 2 months? 2 months, maybe a little bit more. But we're nearing completion. And I'm not going to be putting the final touches on stream, or the final enough touches on stream. I want to leave a little bit of a surprise. So it'd be like, hey, what's around that corner, or whatever. But I think to wrap up the night, we're not going to bring the new gears in or anything yet. Ooh. Exciting news, though. I don't know if it's because I'm using the commercial trial version or whatever of Fusion, but I was able to export the assemblies for the back of the back of the lens. They did export nicely as FBX files, and they do come into Maya now. So I can easily add in the stuff that I did put the time in to 3D model, or well, CAD model, that go on the back of the lens. So that'll be in the near future. The next time we're doing all this, so next Monday, next Monday's plan will be to, one, show off the 3D printed neck, probably not attached. It's a lot of work to have the robot going at the same time as doing all these shenanigans. But I'll show off the 3D print part of it. And I think next time we are going to do the lens assembly. We'll 3D model it, do a little bit of touch up and refining in Maya, bring it into here, bring in the LED and aperture assembly, which is the part that fits on the back of the lens. And then we'll get it hooked up. So it moves. And then, Nix, if you're still here, then we can start hooking up Nix's idea of connecting the VTuber model to the environment. You do still be here? Yeah. Because I think I don't want to just have these gears turning like when I'm nodding and side to side stuff. But at least be able to toggle on and off. To have the lens gyro going. So it'll be tilting and moving. This servo here is connected to a bar over here. Little aperture levers, little movement. And even if it's not connected to my tracking, because it won't be right away. We don't have that stuff in this project yet. I at least want a little animation going of it moving, so what it would be doing. But the plan is, once we bring it into the final unified Rusty Land project for my broadcast environment. Yeah, this room will be connected to my tracking. And I just think that's gonna be awesome. And I do like it, multiple effects. One, it's cool. You're inside the robot's head, the constructed robot's head. But you can lead the tour. Well, by you, I mean me. I can lead you on a tour of the inside of Rusty's head. So when somebody says, well, hey, cool robot, how does robot? Well, you see me nod my head from side to side? This is how we're doing it. I'm gonna say this, it almost looks like a pool table or like a, pinball machine or something. But yes, here's Rusty's control board. Really not a whole lot to it size-wise. What did I say? About 52 millimeters across. So as we see the end of it, 52 millimeters that way, I believe. Yeah. All right. On that happy note. Oh, we do not have colliders on any of this other stuff. But yes, next time, wires and the lens. Wires and the lens. I know just from playing around with it before that the lens gyro, when I say gyro, I mean how it rotates with these rings, like a gyroscope. So the rings rotate within one ring rotates, and then the other one rotates within that one. That's how the lens moves around or tilts around. They're not properly set up in this export, so I have to redo that anyways. But yes, so that's next Monday, which is also our next stream, because stuff going on. Oh, sorry for the ad break right at the end here. Stuff be going on for the rest of this week. Yeah. But yeah, progress is progressing. And I don't know, one of the cool things, I know I've said it before, but one of the cool things about 3D modeling or being 3D is having a physical representation of the model of your avatar. Immersion break, right? It's like I have pieces on my desk right now that I was showing you all earlier. These are part of my VTuber. I don't have them here. I don't have them on the model. Maybe in my next version, I'll add them in, or maybe in the high res. If I do a high res model, I will definitely add in. We'll definitely add in the gears. You get the little gear ASMR there. All the little gears and wires. Because with this back and forth of creating it real, in the real world, bringing it into 3D, creating in 3D, bringing it into the real world, this whole neat cycle that, if I'm going to brag a little bit, it kind of sets me apart. Not everybody's doing something like this. But it's neat having a Facecam streamer that is also virtual at the same time. Not just a, yeah, you get what I'm saying. You get what I'm saying. And this whole project is a fun experiment and just fun to play with. Get my 3D skills back, but also, just creating something that I enjoy. And I hope enough of you enjoy too, or at least following along and listening to me ramble on in my my endeavors and see what we create with it. But on that note, we are going to find somebody to raid and run. So I want to thank y'all for stopping by. And if I don't see you around the internets, then we'll see you next Monday and next Wednesday. Just not this Wednesday. There is there's a noodle cat. There's a noodle cat. Looks like they're still online. Okay. It doesn't look like they're ending quite yet. So we are going to start the raid. Don't forget though, we do have a YouTube. I will be adding to it. But the raid message, I gotta shorten up that command. Rusty Raid. Rusty Raid. And catch y'all around next week. Thank you again for stopping by. Let's go drop in a Noodle Cat. They are working on their cool streaming game, the old Snake game, but live and hooked up to VTuber stuff. So that's cool. It's coming along pretty good. Let's drop by, say hi, and again, catch y'all next time.